Hey, welcome back. Good to see you guys again. So today we're just doing a short video on algebra review using budget constraints. So as I mentioned in the last video, budget constraint or a feasible set is the set of all affordable bundles given a set of prices and an initial budget. So let's go to an example where we have two goods. Let's call them, just to make it easy, let's call it good X and good Y. So the budget constraint is going to be, if it's a simple situation, it'll just be a straight line. So let's say we have $20 a month to spend on two goods, and the price of good X, is equal to $5 a month, and the price of good Y is equal to, let's call it $2 a month. So as I explained in the last video, it helps to start off by, in order to visualize the budget constraint, it helps to start off by calculating the intercepts. So the x-intercept in this case is if you spend all your money on good X, you could afford a maximum of 4. And if you spend all your money on good Y, you could afford a maximum of 10. I obviously did not draw this particular budget constraint to proportionately. Okay, but how do you translate this budget constraint into algebra? Well, the basic equation is fairly simple. So a budget constraint is, you can define a feasible set or a budget constraint as the set of all X and Y combinations, bundles, that satisfy this equation. Px times X plus P sub Y times Y must total the monthly budget. So translating this into English, well, this says that the amount of money that you spent on good X, which is equal to price of X times the quantity of X that you purchase, plus the amount of money that you spend on good Y, money on good Y, money on X, must be less than or equal to your budget. And any combination of X and Y that satisfies this equation is the budget constraint or the feasible set. So it's the set of everything within this triangle. And you can manipulate this simple equation in a couple easy ways, in a couple useful ways. So first, if you want to translate this equation directly into a graph, it helps to put it into the Y, if you go back to middle school, helps to put it into the Y is equal to mx plus b format. So going back to middle school, b was always the y-intercept, and m was always the slope. So it's just a really easy way to graph lines. And I think most schools in the United States teach it that way. Many schools around the world as well. So how do we translate this feasible set equation into the more convenient and more useful equation for a line? Well, first off, we want to isolate y on the left-hand side. So we could start by subtracting pxx from both sides. So you get pyy is going to be equal to m minus pxx, because we subtracted pxx from both sides. And I turned the less than or equal to sign into just an equal sign, because this is just the equation for the line. This is not the equation for the whole set. And then to isolate y, just like we did here, to do this similarly, we can divide through by py. We can just divide through by py, divide everything by py, and you get y is going to be equal to m divided by py minus px divided by py times x. And then notice that this is in the convenient y is equal to mx plus b format. In this case, m divided by py is equal to b, and negative px divided by py is just equal to m. So we know that in any budget constraint, the slope, or any straight line budget constraint, the slope is always going to be equal to the negative of the price ratio. And this is a really important point here, because this economic interpretation of the negative of the price ratio is the opportunity cost of good X in terms of good Y. X in terms of Y. So as long as you know the prices, you already know the implicit opportunity cost of purchasing one additional unit of good X. And you can see this in the graphically really easily. If you want to move from 3 units of X, to 4 units of X, the opportunity cost is the amount of units of good Y that you have to give up, which is going to be equal to the slope. So if you have to give up, in this case, the negative px all over py is equal to negative 5 over 2. So that means you have to give up 2.5 units of good Y in order to gain 1 more unit of good X, i.e. the opportunity cost. So this is really simple algebra, but it's really useful to keep in mind what the slope of the budget constraint is telling you. And in this case, because m was equal to 20, so we know m over py is equal to 20 divided by 2, which is equal to 10. We very quickly can see that this m divided by py is equal to the y-intercept, which is b, in the y is equal to mx plus b formulation. So this is just, that's it. This was just a quick review of some basic algebra for dealing with lines and manipulating equations, which is always useful to review.